Welcome to Study Time, a televised home learning program produced by Rwanda Basic Education Board.
Hello, Senior 3 students, chemistry class. You're most welcome for today's lesson. I think you're very fine. All right? Are you fine? Good. So, today we are continuing with Unit 2, and I think we're going to put an end on it. That is nitrogen and its inorganic compounds. All right? So I've been looking at some of the inorganic compounds of nitrogen, their preparation, properties, uses. So we are going to look at now nitrates. So nitrates, that is today's lesson. What is the objective? You may ask yourself, when I study about nitrates, what will I be? What is the major thing that I have to come out of this lesson today? So the major thing you have to put note of, you will know by the end of this lesson the laboratory preparation of nitrate, the properties of nitrates, and you state the uses of nitrate in everyday life. Why do we need to make nitrate? Why do we need to manufacture nitrate? Why do we need to prepare nitrate? Those are the reasons or the uses of nitrates. All right? So let's start, and if you're ready with a book, a pen, let's start and look at nitrate. We start by looking at the laboratory preparation of nitrate. Right? The laboratory preparation of nitrate. So nitrates, what are nitrates? Nitrates are salts which are formed when hydrogen ion in nitric acid is replaced by a metal or ammonium ion. I repeat this. Nitrates are salts. They are salts. How are they formed? They are formed when hydrogen ion in nitric acid, this is nitric acid we are talking about. So when hydrogen ion from nitric acid are replaced by a metal or ammonium ion, they are replaced by either a metal or ammonium ion. For example, if we remove this hydrogen and we put the ammonium, we form ammonium nitrate. So get any metal here. Let's get sodium is a metal, you know. Replace hydrogen of nitric acid, have sodium nitrate. Can be calcium. Calcium nitrate. Calcium nitrate, but we put a 2 here. Since calcium has a valence of 2, nitrate has a valence of 1. Sodium has a valence of 1, nitrate has a valence of 1. That's why we write sodium nitrate. So calcium, we put a bracket, a 2, because calcium has a valence of 2. You remember that in senior 1, I think. The valences. So this is how we form nitrates. So when we replace hydrogen of nitric acid with either ammonium ion or any metal, we form nitrate. What we get is called nitrate. So we have sodium nitrate, calcium nitrate, ammonium nitrate. All right? So let us see in the laboratory how nitrate is formed. How do we achieve this we are talking about? One is neutralization of nitric acid, what we call neutralization reaction. What is a neutralization reaction? We have been talking about in the previous lesson. We talked about neutralization reaction, or we are used to that. What is neutralization reaction? Yeah, the reaction between an acid and a base to form salt and water. Only, we normally prefer that word, only. So when there is neutralization of nitric acid with a base or alkali, we get a nitrate. So for example, you get N hydroxide, get sodium hydroxide plus aqueous nitric acid, as we said. You will get sodium nitrate, aqueous, plus water, liquid. All right? This equation, we call it neutralization reaction. A reaction between a base or alkali with an acid. Any neutralization reaction is any mineral acid. It can be nitric acid, can be concentrated, sulfuric acid, hydrochloric acid. But for our case today, we are looking at laboratory preparation of nitrates. So here, we take an example of nitric acid. So when we react any base with nitric acid, you get nitrate, that is sodium nitrate, plus water. All right? So that is one way of forming nitrates. This is a nitrate, it is a salt. Under neutralization reaction, we can get nitrates. Another way that the solution, when the resulting solution is heated to dryness, a white solid nitrate is obtained. So when you heat, this one contains some water, all right? It contains some water. So when you want a dry nitrate, you just apply heat. So a white nitrate is obtained. So this method is suitable for preparation of nitrates of potassium, sodium, and ammonium. All right? Good. So another way to get nitrate is the reaction between nitric acid and metal carbonates. So when we say metal carbonates, that is a metal with carbonate. It can be calcium carbonate, magnesium carbonate, lead carbonate. So a metal carbonate with nitric acid, you will get nitrates. Get an example? When we have one is neutralization reaction. So we prepare nitrate by neutralization reaction. Another way you can react nitric acid, reaction between nitric acid and metal carbonates. Take an example of lead carbonate. Plus, this is solid, plus nitric acid, aqueous. we get lead nitrate, which is aqueous, plus carbon dioxide, gas, plus water, which is liquid. All right? So this is the second way of preparing nitrates. This is a nitrate we have got here. This is salt here. This is a nitrate, lead nitrate. So is it balanced? Have lead. We put a 2 here. We put a 2 there. Let's count and see. Lead 1, lead 1. Carbon 1, carbon 1. Oxygen, you have 2 oxygen, 2 times 3, 6, that is 8. 3, 3 plus, these are 6, plus 3, those are 9. Have 3, 5, right? We are trying to balance it out. We have here lead, which is 1. Have lead, which is 1. We have carbon. Carbon is 1. All right? Carbon is 1 here. Carbon is 1. We go to oxygen. We have oxygen. These are 3 plus 6. Those are 9. So we have 2, 7. We put a 2 here. All right? So when we balance, we get those are 6, 9. All right? Plus 9. Then here we have 2, 5, and 2. 7 and 2, 9. Have 4. So you try to balance it out, all right? Try to balance it out and see if it comes out very well. 2, so go on the slide and see. Go on the slide first. First go on the slide, have 2 hydrogen. 2 hydrogen, all right? Have nitrogen 2. Have 2 nitrogen because we multiply this. So the lead 2 nitrate, you remember lead has a valence of 2. I have a 2 here. Have a 2 here. Lead has a valence of 2. You remember that. Lead has a valence of 2, and here now it is balanced. It is balanced because lead has a valence of 2, and the nitrate has a valence of 1. So we put the whole of nitrate in a bracket. You remember radicals in senior 1, all right? You remember radicals in senior 1. When we talk of radicals, their valences are calculated for us. Their valences are there. So the radical nitrate, its valence is 1. The whole of nitrate has got, you don't say nitrogen or oxygen. No, it's together. All right? Its valence is 1. And we are talking of lead 2. So if it is a lead 2, lead has got a valence of 2. Then nitrate has got a valence of 1. So we put a bracket, and we put a 2 here. So when you pass through this, now you find it is balanced. It is balanced. Sorry, it's balanced now. This is the salt I was talking about. So let's balance again and see. Lead 1, carbon 1, carbon 1, oxygen, these are 3, 9, these are 6, plus 2, those are 8, plus 1, those are 9. Hydrogen 2, it's now balanced, all right? So that is it. So we can also get, another example of any other carbonate, metal carbonate. We have calcium carbonate plus nitric acid. You get calcium nitrate plus carbon dioxide plus water. All right? That is also another metal carbonate. So you get any metal carbonate, react it with nitric acid, you will get nitrate. All right? Good. So what is another way of preparing nitrate? So remember, we're trying to see how to prepare nitrate. So action of nitric acid on a metal. So get a metal, react it with nitric acid, you will get its nitrate. For example, we have got magnesium plus nitric acid, you get magnesium nitrate plus hydrogen gas. But this is suitable to use, or this method is not suitable for use with very reactive metals like sodium and potassium. It's not suitable for preparing salts that are readily oxidized, that can easily oxidize. For example, a salt that can be prepared by this method is magnesium nitrate. That's why we're giving an example of magnesium metal, reacting it with nitric acid to get magnesium nitrate. On the slide, you can see the equation. You should always know how to write very well the equation. So magnesium plus nitric acid, you get magnesium nitrate plus hydrogen gas. All right? So those are the three major ways in the laboratory that we use to prepare nitrates. Do you have any questions there? So what are the three methods? One is the neutralization reaction of dilute nitric acid by alkali or base. So get N hydroxide, react it with nitric acid, you will get a nitrate plus water. So another way is to react nitric acid with a metal carbonate. You get any metal carbonate, react it with nitric acid, you will get its corresponding nitrate. When I say corresponding metal carbonate nitrate, that's that metal carbonate you have used, that metal you have used. If I've used calcium, it will be calcium nitrate. If I've used magnesium, it will be magnesium nitrate. If it's lead, like that. It's corresponding metal nitrate plus carbon dioxide and water. And then when you use nitric acid on a metal, specifically here we prefer magnesium metal. So it is majorly used to prepare magnesium nitrate. All right? So magnesium plus nitric acid, you get magnesium nitrate plus hydrogen gas. All right? Good. So those are the three major ways on how you can prepare nitrates in the laboratory. So what are the properties of nitrates? What are some of the properties of nitrates? Here we put emphasis on the action of heat on nitrates. Action of heat on nitrates. So we are saying that all nitrates decompose on heating. Right? So all nitrates, when you decompose them or when you put them, we apply heat on them, they will decompose. So one, let's look at sodium and potassium nitrate on heat. So when sodium and potassium nitrate undergo heating, they produce their corresponding metal nitrite and oxygen gas. That is, if it is potassium nitrate, under heat, it produces potassium nitrite. When it is 2, we say nitrite plus oxygen gas. All right? So if it is sodium nitrate, it will produce sodium nitrite plus oxygen gas. How about these reactive metals, most reactive metals like sodium and potassium? So they moderate reactive metals. What happens for the moderate reactive metals? For the moderate reactive metals, they produce their oxides nitrogen dioxide and oxygen gas. When I said their respective or their corresponding metal oxide, that means if it is lead, it will produce lead oxide. If it is zinc, it will produce zinc oxide. If it is copper, it will produce copper oxide. So that's why I use the one word to represent all of them, and I say they will produce their corresponding metal oxide, nitrogen dioxide, and oxygen gas. So the moderate reactive metals will produce their corresponding metal oxides, nitrogen dioxide, and oxygen gas. How about the least reactive? The least reactive metals will, like mercury, will decompose to give metal, their corresponding or their respective metal, nitrogen dioxide and oxygen gas. Take an example of mercury or silver. When silver undergoes decomposition, when you apply silver on heat, you get silver plus nitrogen dioxide plus oxygen gas. So that's how nitrates undergo decomposition, or when you apply nitrogen, heat on nitrates, the most reactive will produce their corresponding or their respective nitrite plus oxygen gas. The least, or the moderate reactive, they will produce their respective metal oxide, nitrogen dioxide plus oxygen gas. Then the least reactive metals will produce their respective metals plus nitrogen dioxide plus oxygen gas. That's how the action of heat on nitrate happens. All right? Good. So we can go and look at the uses of nitrates. Because the objective, we remember, in the objective, we have to state the uses of nitrates. Is it, class? We talked about that. I emphasized on that we shall look at the uses of nitrates at the end. So what are the uses of nitrate? Why do we need nitrate? So nitrate is used as a fertilizer. For example, sodium nitrate, potassium nitrate, ammonium nitrate, calcium nitrate, the NPK fertilizers. So potassium nitrate is number 2. Potassium nitrate is used in manufacture of gunpowder. All right? The gunpowder is nitrate is used in manufacture of the gunpowder. So it is a mixture of potassium nitrate, charcoal, and sulfur. So when ignited, the mixture burns and explodes. Ammonium nitrate is also used as a fertilizer and also in the manufacture of explosives. So nitrates in the form of nitroglycerin are used in medicine for treatment of heart diseases. So you see, nitrate is very important. So it is used in the treatment of heart diseases. All right? Are we together? Good. So the last point to talk about here is to see what are some of these nitrates and the nitrogen dioxide, as we discussed them in the previous lesson. There are sometimes, though we are saying they are very important, but sometimes you find that they are hazardous, they are of a big problem to the environment. So what are the environmental issues with nitrogen dioxide and nitrate fertilizers? One, the nitrogen dioxide released in the atmosphere pollutes the environment. How? When the nitrogen dioxide meets the rain, it forms acidic rain. So the acidic rain comes and destroys the vegetation, animals, and buildings. That is a disadvantage. How about nitrate? Nitrate fertilizers. So when you apply nitrate fertilizers on this farm, well and good, they will help to grow your crops. But in the long run, when rain comes, and there happens what we call soil erosion, the topsoil together with those nitrate fertilizers are washed. Let's say there is a nearby river. When they accumulate those fertilizers, when they accumulate in a nearby river, they will lead to outgrowth of unwanted plants in the river. Then those plants will lead to competition. They be what we call eutrophication. There will be competition of oxygen from those outgrowth plants together with the aquatic plants and aquatic animals. At the end, the aquatic animals will suffocate, will die because of low or inadequate oxygen. So these fertilizers are very important, but we are saying at the end of the day, they become a problem by leading to what we call pollution, water pollution, in other words, eutrophication, competition for oxygen by the aquatic plants and animals with the outgrowth, the unwanted plants that have grown in the river as a result of accumulated fertilizers in the river banks or on the river banks. All right? Good. So you have been very attentive. I can't doubt that you have picked what we have been talking about here. So to see if you have picked exactly what we have been talking about, I leave you with around 3 questions. You go and try them out. When we come back, we start from there. All right? So thank you so much for your good attention. Let's meet in the next lesson. Next time, bye.